and everyone. I am Thuong. Today I would like to present the topic Asian-based modeling for landslide susceptibility assessment. This is the outline of my presentation. I want to introduce some basic information about Asian-based modeling as well as an expected plan to construct a model for landslide susceptibility assessment in Vietnam. As we all know, recently, Asian-based modeling is a popular approach for representing, studying, or exploring complex geographical systems. So, what is an Asian-based model? According to Laubenbacher, an Asian-based model is a computer model that consists of a collection of Asian or variables that can take on a typical finite collection of states. The state of an Asian at a given point in time is determined through a collection of rules that describe the Asian interaction with other Asians. These rules may be deterministic or stochastic. The Asian state depends on the Asian previous state and the state of a collection of other Asians with whom it interacts. There is no universal agreement amongst researchers on the precise definition of the term Asian. From a pragmatic modeling standpoint, there are several features that are common to most Asians. These are briefly presented as below. Firstly, Asians are autonomous units, meaning governed without the influence of centralized control. The next one is heterogeneity. Asians permit the development of autonomous individuals. The third one is Asians are active because they are exert independent influence in a simulation. Finally, Asians can be also designed to be adaptive, producing complex adaptive systems. This list is not exhaustive or exclusive within an application. Asians can possess other characteristics, and for some applications, some features will be more important than others. Often, there are many different types of Asians within one simulation. Figure 1 here illustrates the creation of artificial worlds populated by Asians. There are three main claim advantages of Asian-based approach over traditional modeling techniques. The Asian-based approach captures immersion phenomena. This method provides a natural environment of study of certain systems. It is flexible, particularly in relation to the development of geospatial models. The change in modeling techniques using Asian-based modeling over traditional Asian-based modeling is listed in this table. For instance, difference with deterministic traditional models, which provide only one feature. Asian-based models can show multiple features. The adoption of Asian-based modeling approach was greatly fueled by the emergence of increasing powerful software platforms. These last years have seen the development of many platforms, toolkits, and frameworks dedicated to the implementation and simulation of Asian-based models. One of the possible criteria to classify these platforms is the type of language used to define the models. Three categories can be defined as follows. The first one is a platform allowing the DeFi model with a genetic high-level programming language such as Java or Python. Raiden, Repass, and Commas are three typical examples of this category. The second type is a platform allowing to define models using specific modeling language. These platforms are often simpler to use than the ones in the first categories and are dedicated to a wide range of users. Let's Logo and Gamma are two popular platforms of these categories. The last type is a platforms allowing to define a model with a graphical modeling language. These platforms often require no or few knowledge in algorithm, but are very limited in terms of richness of models that can be built. Start Logo, TNC, and Asian Shift are two examples of this category. Among many platforms dedicated to implementation and simulation of Asian-based model, the GIS and Asian-based modeling architecture, or GAMMA in short form, was developed to combine all the advantages of previous tools in order to provide modelers with a simple-to-use Asian-based programming language, a powerful management of geographical data, flexible visualization tools, and the capacity to carry out simulation with hundreds of thousands of agents. For the reason, I plan to use this platform in my study. So let me introduce some basic information about this platform. One of the reasons to the success of modern modeling platforms comes to the fact that they are, they are integrated platforms allowing to switch very easily between a modeling perspective, meaning writing of the model code, and a simulation perspective, meaning running of the simulation. This possibility has a deep impact on the modeling process and on the modeler habits. Rather than waiting to have a complete model before running simulation, the platform allows modelers to experiment very quickly the impact of the modification of the model code and consequently favors a test and try modeling approach. The Gamma platform follows the same concept but proposes more advanced modeling and simulation tools. Gamma is known as Advanced Integrated Development Environment for Agent-based modeling and simulation. In addition, Gamma provides a powerful modeling editor aiming at easing the modelers at work, as can be seen in its modeling interface. This editor integrates all the classical tools such as auto-coloring, auto-compilation, auto-completion, and the possibility to automatically format or comment some lines of code. It allows to define code templates which facilitate the development of models by sharing snippets of code between models. In addition to compilers of models, integrates Gamma also integrates an interpreter of the language called Gamma Modeling Language that is an agent-oriented language, allowing users to directly interact with agents to get a direct feedback of the execution of the code. This console is available throughout the platform, allowing, for example, to execute lines of the code, change the preferences of gamma, or consult the documentation even when no simulation is running. Gamma takes its roots in gamma, but extends the object orientation programming, an approach with powerful agent concept to allow a better expressiveness in models. The interests of coupling GIS and agent-based modeling have been identified by many studies. However, most of existing agent-based platforms still propose a weak integration of GIS data in simulation. Gamma was developed from the beginning to overcome this limitation. Indeed, Gamma allows to naturally integrate GIS vector and raster data. It allows to manage several representations of the same environment with different spatial organization. In Gamma, all models are provided with continuous three-dimensional environment. And an important feature of Gamma is that, like in a GIS, all agents are spatialized, meaning that all agents are provided with a georeference geometry. This feature of Gamma brings more advantage to the modelers in simulation of geographical systems. As models tend to be more and more complex and descriptive, it's become more and more difficult to reuse them in different contexts. Gamma allows as well to go further with enabling to distribute the execute of agents on several threads. The platform is also particularly adapted to manage the coupling of models by its native support of co-modeling and multi-simulation. In addition, Gamma enables to easily differentiate a model from its visualization by offering the possibility to define different displays per simulation composed of several layers. Moreover, Gamma is integrated agent-based architecture based on the belief, design, and intention paradigm. All of them lead Gamma towards more complex models. Here is an example of the use of multi-simulation. For simulation concerning ants forensic are run in a parallel with four different sets. The left chart shows in real time the results of four simulations in terms of food gathered. In next part, I will talk about some idea of building a model for landslide susceptibility assessment in Vietnam. The motivation of this work is because landslide is one of the most damaging geological hazards worldwide, threatening both humans and property. And our Vietnam is one of the top 6 countries frequently affected by natural disasters, including landslide. According to Vietnam Disaster Management Authority reports, only in October 2020, landslide occurred 11 times in Vietnam, causing serious damage to people and properties with 110 deaths, hundreds of injuries, and the estimated initial economic damage caused by natural disaster, including landslide, being over 28,000 billion Vietnam dong. That means about $120 million US dollar. The figure for here is a landslide occurring in October 18, 2020. Buildings of a military unit in Quảng Trị province in central Vietnam are buried following a landslide caused by heavy rain. 22 people were killed in this landslide. Even though models have been applied successfully in landslide susceptibility assessment, however, no model is totally perfect. In addition, location at which the model is developed may be different to the other location, so models of the natural environment are not often applicable when extrapolated to new areas. As I have mentioned before, action-based modeling is now a population approach for representing, studying, and exploring complex geographical systems. So, these are the motivation to propose an action-based model for landslide susceptibility assessment in Vietnam. Here are the general flow work of the study. Based on the model objective, the model factor will be determined, and then the data for these factors will be collected and processed. The data processing using GIS tool. The model is then constructed and simulated using data that's already processed. The following step is model calibration. Finally, the landslide susceptibility assessment will be established relying on the result of model simulation that is built using the Gamma platform. The main expected result of this work is to build a simulation model for landslide hazards in Vietnam, and based on this model, establishing landslide maps and assessing landslide susceptibility in Vietnam. Here is my references. That is all of my presentation. Thank you for listening.